Hi there, and welcome to the Ethanol Producer Magazine podcast. I'm your host, Anna Simet. We're here at the International Fuel Ethanol Workshop and Expo in St. Louis. I'm here with a couple of folks from RCM Thermal Kinetics. We have Andrew Cancillia, Process Engineer, and Ken Crawford, Engineering Manager. Andrew and Ken, thanks for being here, and welcome to the podcast.
Thanks for having us.
Yeah, it's great to be here. Thank you.
Yeah, we're so happy that you're here at the show and chatting with me today. I think let's start by having you guys tell us just a little bit about RCM background and what you guys do.
Yeah. You want to go ahead?
Yeah, sure. As a company, we were initially Thermal Kinetics, founded in the 90s, I believe, with a really heavy focus on energy integration and optimizing just general chemical systems. Mm-hmm. And then in the 2000s, the founder really just came upon the booming fuel ethanol scene and brought his mindset of energy efficiency and heat integration into the ethanol world. Okay. And there's actually a few thermal kinetics fuel ethanol plants that are in operation currently. And we have some patents on low steam, low pressure DD&E systems in fuel ethanol.
Okay.
Yeah, in addition to the fuel ethanol world, we also have a pretty diverse network of offerings for the chemical industry. So we have our own lab facility, which hopefully we'll get a chance to talk a little bit about later too.
Yeah,
okay.
That's pretty cool.
Oh, awesome. Okay, thanks, guys. Let's get into the questions. So many ethanol producers want more capacity, but they're cautious about major greenfield spending. How is that changing expansion strategies today?
Yeah, so the opportunity is already there with a lot of these existing facilities. A lot of them were built very cautiously, mm-hmm. I would say, and there's a ton of opportunity to expand capacity without really adding on new sections or an entirely separate plant. Mm-hmm. So since that opportunity is already there, what we as a company can do is help leverage that.
Okay.
And take a really detailed look at every facility because they're all unique and they all have special advantages, but also their own difficulties that they face. And we can take a look at every specific plant and basically point out where their bottlenecks are and give a special and unique strategy for them to increase capacity, mm-hmm. produce more ethanol, and not have to add on major equipment or entirely new sections of the plant.
Mm. Okay. So what DD&E operational issues cost ethanol plants the most money today?
I would say there's a few, right? Mm-hmm. Uptime is a big one. The utilization and uptime is a major concern that we've heard many customers be very adamant about fixing. We've had some projects that have just focused on improving utilization and improving uptime without necessarily a focus on increasing capacity. Because, if you're down for more than 2 weeks per year, that's a significant, that has a significant impact in bottom lines. It has a significant impact in revenue.
Right.
And I think what you're seeing is now that a lot of these plants are being pushed further and further, they're starting to have more issues with fouling. So systems are being run at higher temperatures and higher pressures than what they were initially designed to be at. Well, that's causing some of the dirtier processes in DD&E to have issues with fouling, especially in heat exchangers and EVAPs and in beer columns too. So when that happens, now you see people having to clean more often, CIP more often, and there's cost associated with all of this. So having a really strong focus on the temperatures and pressures that specific pieces of equipment, beer columns and evaporators are running at, mm-hmm. Can really help just try and optimize, minimize really fouling that's happening in the plants. But in addition to that, everybody's talking about efficiency, CI scores. And as a company, we have that background in, we have the background in high efficiency. And we have patents. We are comfortable with any technology, really, and mm-hmm. We're willing to, adopt where we've worked with MVRs. We can work with membranes, and we're open to optimizing efficiency and CI score for any customer that we have.
Okay, great answer, Andrew. My next question is, why is debottlenecking distillation so important to the operation of a successful ethanol plant?
Yeah, that's a great question. I think no matter the design, whether it's an ICM, a TK design, Delta T, distillation is really, really, really heavily integrated into the rest of the plant. You have not only mass flowing from distillation, but you also have a lot of energy streams that are connected between distillation, evaporation, mole sieves. Distillation is really the heart. I gave a presentation yesterday, and I said it was the first D in DD&E. Distillation, if you have problems with distillation, it's not optimized if you're running at too high of temp or you're fouling, pressure drops too high. That can have a cascading effect, a trickle down on the rest of your DD&E. And maybe there's a problem with distillation that could, depending on what type of facility you operate, that could be observed. Like you could see the results of that in evaporation, for example. Like just giving an example off the top of my head, if your pressure drop is too high in your columns, okay, well, that might cause your evaporators to pressure up, and the results of that high pressure drop in your columns could now be seen in the evap fouling more than it needs to be. Of course, depending on what your facility is and the process flows that are going on. And there's usually a lot of room for distillation columns to be optimized too. It's impressive to me because distillation is this 1,000-plus-year-old technology. But even since the big boom in the 2000s with all of many of these fuel ethanol plants being constructed, distillation has advanced since then. And there's a lot of new technology which can help limit pressure drop, prevent fouling, increase flow of vapor and liquid through the columns. So that technology hasn't really made it into the ethanol world yet, and we're trying to push it in with our partners as much as we can because, like I said, there's a lot of room for optimization of these plants, and you don't necessarily have to build a new column to get more flow through distillation. So we're very focused on optimizing distillation in addition to looking at mole sieves, looking at even membranes and evaporation, just to basically optimize your facility and look at the bottlenecks that your facility has. But yes, distillation, always the most important.
Some great insight. Ken, let's move to you.
Great.
You made a presentation about a DD&E revamp and some of the details involved in the execution of that project. What are some other projects that you're involved in?
So right now, like Andrew mentioned, we have a pretty heavy focus on DD&E revamps, which is great for us and it's great for the industry because we're able to offer improvements in production or reduction in downtime without major greenfield expansion. But Thermal Kinetics also gets involved in all sorts of different projects. We can supply, historically we've supplied all the major equipment for DD&E facilities at our within our patents. So we've supplied equipment for entire greenfield facilities. We do engineering studies at all kinds of ethanol plants, including CO2 scrubber analysis. As part of our revamp studies, we send engineers into the field to collect field operating data that facilitates our revamp approaches. And we can also do single unit operation analysis. So we've supplied degassers to a lot of plants where they need optimization of the degas upstream of the beer columns. So really any step along the way within distillation, dehydration, evaporation, we have a wealth of experience, and we've worked on simple projects to replace small key components, or we've done entire plant evaluations. So, whether it's a filter that needs to be replaced or a tank that needs to be optimized or an entire set of evaporators that need to be analyzed and replaced and optimized. We've looked at all those over the years. And then Thermal Kinetics outside of the fuel ethanol world also has quite a few customers and the ability to work on those projects. So we've worked at rolling oil recovery systems in aluminum mills. We've worked on crystallizers in the food industry. Anything that involves heat or mass transfer, distillation, evaporators, crystallizers is something that we geek out about. We love to work on those kinds of things. we talked briefly just about the lab. It got mentioned earlier on. We've got a lab facility at our office in Amherst, New York, and we're able to do lab scale studies of distillation, evaporation, and crystallization. So sometimes a customer will call us up and say, hey, we want to try to separate these two components. How big of a distillation column are we going to need, or can how far can we get this to the azeotrope? And we can run those kinds of studies in our lab, and that gives us an opportunity to work with the customer to develop the project, but then also, it gives us a foot in the door so that we can work on the larger engineering projects, the FEL1 studies, and then the OPEX and CAPEX studies that would be involved in building a full-size plant.
And it's that background that we also have beyond just fuel ethanol that we can bring to the table.
Mm-hmm.
Like Ken said, it's more than just fuel ethanol. We work with crystallizers, we work with rolling oil recovery. This is experience that we have beyond just fuel ethanol, but it's all very important insight that we can gather, and just a very useful engineering background that we can bring to the table.
Speaking of that experience you guys are talking about, what are some lessons that you have learned from other projects that apply to DD&E revamps?
Yeah, so one of the cool things about having the lab and the way that we approach our revamps, it gives us a kind of a full spectrum approach. So we see projects at the very initial stages where we're trying to work through kinks in a beaker in a lab scale study, and then we've also worked on the installation and the startup and the commissioning of a project. So we've seen things from initial, it's embryo stage all the way through full growth and implementation, it's cool and fun to be able to do that. So that gives us a perspective on all kinds of phases of the project. And then specifically for revamps, some of the lessons we've learned is that being in the ethanol plants there's a lot of things that are very similar in a lot of ethanol plants, but then every ethanol plant is unique, right? Which is a blessing and a curse. So, that exposure to oversized heat exchangers or undersized distillation columns or whatever the case may be, those engineering principles are relatively easily applied to all kinds of different other revamps and projects in the fuel ethanol world and outside the fuel ethanol world, right? So it's having an understanding of distillation and heat transfer and mass transfer that can be applied to all phases of the project. So a couple of specific lessons learned that I presented on yesterday were that steam piping. So we recently supplied a new vaporizer, a 190 proof vaporizer and steam condensate tank for an MSU expansion, and the steam piping in that particular state was classified as high pressure piping, and it was a detail that unfortunately had been overlooked initially, but we were able to troubleshoot it, work around it, make sure we had all the permitting and application and inspections done properly. Mm-hmm. And that's a lesson that is burned in my memory banks now, and I will never forget it. But it's also, taking those lessons, being honest with yourself, being able to look back at the end of a project and have a lessons learned meeting, which we always do, and say, hey, what are the things that we can improve on to make sure that the next time we have a similar project or anything close to it, what can we learn to improve better on our execution?
Well, thank you. Great conversation, you guys. Some really valuable insight that you've shared. Is there anything else that you want to add before we wrap things up?
I can't think of anything in particular. It's a pleasure being here, chatting with you. It's been really nice. This was my first fuel ethanol workshop, so it was a great experience. We're already looking forward to next year in Omaha. So,
well, thank you guys for being here, and thank you so much for coming on the podcast.
Yeah,
appreciate it.
Thanks for having us.
And to our viewers, it's Ken and Andrew from RCM Thermal Kinetics. Hope you enjoyed this episode. We'll catch you later.
Cheers.